on near about 6 years. Okay, so let's start with the things, right? So how it is. Okay, so maybe you know warehousing background or not. So I'll be giving a brief idea on data warehousing flow, and then we'll jump into the Abinitio part, right? Okay. So why we need data warehouse, right? What is the purpose of data warehouse, right? So you know that data warehouse is a database, right? Which we store the data of the business, right? So any idea on the warehousing? What is a warehouse? Other than Prasoon, as he worked on ETL, so Vamshi and your colleague.
Yeah.
Any idea what is
Data
a
warehouse
warehouse?
is like you use it for more analytical purposes.
Mm,
Yeah, it's like data gathered from multiple sources, and it is what do you say, structured in such a way that it will be more useful for the reporting and all.
right,
Hello?
right. Yeah, that's correct. Okay, so you know that, right? Data warehouse is a database which will be storing the current data and the historical data, and it is used for reporting and analysis purpose. Okay, so when we compare with the normal databases, the data warehouse size will be more, and it is huge. We'll be having huge volume of data which we will be storing it, and as we know that ETL will take the data from multiple types of sources, right? Any kind of source formats the data can be. So it will be a input for my ETL process. Okay, and ETL will perform extraction, transformation, loading part, and then we'll be loading into the data warehouse, right? And once the data is available in the data warehouse, the reporting teams will try to read the data, and then it will show the reports to the end user. Okay, so in this platform, in this warehousing, data warehousing platform, we'll be having two areas, right? One is ETL front, and another one is a reporting, right? So we will be working on the ETL part, where we will be preparing the data warehouse with the help of any of these ETL tools, right? So we will be working on the Abinitio part here. Okay, so other ETL tools and other reporting tools, right? I have listed here. Okay, so in terms of data warehousing application flows, right? So any of the tools you're working with, the data flow will not be changed. It will be the same, right? But what is the difference here is you are seeing some kind of salient features for Abinitio when we are comparing with the other ETL tools. Okay, so this thing will be differing, right, in terms of features, right, which are available in the Abinitio when compared to other ETL tools. Okay, so as you are aware of bit on the warehousing, right, I will not be explaining more on this now, right? We can go with the Abinitio part. So here we can discuss the basics once again when we started our sessions. Okay, so we'll go with the Abinitio front. So Abinitio, what is Abinitio, right? Abinitio is a ETL tool, and it is a Latin word for from the beginning, right? So from the beginning onwards, this tool is giving ETL solutions for many clients, right? And we have listed out many domains, different domains, right? What we have, like banking, telecom, insurance, healthcare, electricals, airlines, retail, right? So we have multiple domains we have, right? So among all these domains, right? So we'll be having more projects from financial services, right? Like banking sector, telecom, insurance, right? All these are having more projects on this front, right? And we'll be having a few projects on healthcare systems, electricals, airlines, and retail market, right? So these are the different domains, right? What we have data, right? And we'll be using Abinitio for as a ETL tool, right? So Abinitio is a ETL tool, and it is a US-based company, right? So where the guys will be working in this tool for creating, developing on the development part of the ETL tool and supporting to the vendors, right? Supporting to the vendors. Okay, so it started in 1996. The tool was developed in 1996, and from 2000, right, around 2000 onwards. So we have so many projects coming up on this ETL tool, and we have more projects now, and it is a costlier ETL tool among all the ETL tools, right? So even it is coming up with the package, right? So like repository and the client and server, right? Everything is provided by ETL Abinitio only, right? And performance wise, this is the topmost ETL tool, right? So wherever you work with the millions of records, the data volumes, okay, you'll be finding that the performance is far better than any other ETL tool. So Abinitio is specifically, right, so stands alone as a single point of, right, ETL tool with respect to the performance. Okay, so this performance is due to the parallelism techniques, right, which makes this tool very stronger, right? So the way we have parallelism techniques in other ETL tools also, right? So according to the architecture and according to the features available in the Abinitio, it stands as a different than compared to the other ETL tools. Okay, that's why the performance is topmost here. Okay, and current version is 3.2 version which we are using. Okay, but as a part of training program, you'll be getting 2.10 version, right, for your practice purpose. Okay, and but I'll be covering the latest features, right, whichever you want to work right now whenever you started working on this Abinitio ETL, right? So we'll be covering all the topics which we will be working currently, but for practical things you will be getting 2.10. So the features available in 2.10 is similar in the 3.2, but we'll be learning additional things, right, which are missing in the 2.10, but which are required for the current developments. Okay, any questions till now?
No.
Are we good?
Yeah.
Okay, so in that case, okay, we'll start understanding the about the architecture, right? So how the architecture will be, right? At what kind of working nature we'll be doing it, right, within the Abinitio level. Okay, so we have a client server model, right? As I said, it's a client server model. So client is a GDE, which is graphical development environment, and server component is cooperating system, right? So this is my GDE, right? Graphical development environment, which is existing on the Windows environment. Okay, it will not change, right? It is always existing on the Windows environment, and this is the front-end interface for a developer, right? So whenever you started working on a GD, right? So what are you going to do using the GD means, okay? You're going to design the graphs, you're going to execute the graph, and we are going to check the status of the graph, right? So all these 3 points, right, will be performing using this GD, right? So like in terms of like suppose say Informatica, right? So in the ETL, right, if you want to perform these 3 steps, right, so you will be doing using different you'll be using these 3 steps using different tools, right? But here we'll be doing it in a single window, right? So it is the simplest way to do the activities using the GDE. Okay, so we here the graph is nothing but it's a collection of components, right? Graph is nothing but it's a collection of components. So we'll be choosing the components as per the requirements, and we'll be defining the properties, and then we'll be building the graphs, right? So the graph is created and it will be saved with the extension .mp, right? So that will be saved like a .mp extension, right? And the relevant .mp will have a .ksh file, right? So which is nothing but it is a shell script, right? It will be created automatically whenever you save the graph, right? That means every graph is having a .ksh which will be created automatically, right, when we save the graph. Okay, and where are you going to save all these graphs and .ksh files, right? So that means nothing but it is available on the Unix machine, right? So your server component, the cooperating system, is available on the Unix machine, right? The cooperating system is available on the Unix machine. Okay, it is being connected to multiple CPUs. The co-operating system is connected to multiple CPUs, right? So the Unix machine here, it is called as a host machine, right? It is called as a host machine. So the host machine contains the co-operating system server component, right? So it's internally linked with multiple CPUs, right? Depends upon your application. You might be having 12 CPUs, 16 CPUs, right? Depends on application wise. Then this is called as a host machine where you're going to store your input files, output files, intermediate files, right? Everything you'll be saving here itself, right? Along with the graphs and the .ksh files, which I explained now, right? That means there is no physical location in the GD to store your graphs, right? Everything will be stored in the host level. Okay, so your server component is existing in the host, right? So GD is only purposefully used for designing the graphs, right, and modifying the graphs. But the physically they will get saved in the host machine, and the server component is physically available in the host. It's been available. So whenever you trigger to run the graph, right? So running the graph will be handled by the co-operating system and the CPUs, right? So this co-operating system is meant for taking care of execution process whenever you run the graph. Okay, so within the GD, I'll be having the connection details towards my host machine, right? So this is a Unix server, right? So this Unix server access, right? So we have to fill the details of the Unix server within the GD to connect to this machine. Okay, so that only the GD and the host is having the relation linkage. Right? So whenever you run the graph, right? Whenever you run the graph, so what are the steps it is been involved with, right? So that is nothing but it's the anatomy of running a job, right? So whenever you run the job, whenever you run the graph, right? So what happens is you triggered the graph from the GD, and it will create one process, right? That means the initial request will be going to the host. Okay, which is called as host process creation, right? So these all the steps are like a background process, right? Whenever you trigger the job, what happens? So the host will receive this request, right? And then this request will be given to the processing nodes, right? It is given to the processing nodes. That is nothing but the CPUs, right? So these are called as agent process creation, right? Each and every CPU will have one process created, and within the agents, the components, right? So how many components you're using in the graph? So each and every component will create one process. Okay, so this process creation will be happen in the agent level, and it will be executed. That is component execution, and it will be terminated. Right? The components will be terminated once the job is completed. So that means the agent will understand that all the components got executed within that agent level, and then agent will be terminating, right, by sending back the request to the host, right? That means the control is back to the host. Okay, and from the host, again, the request will be sent to the GD. That is nothing but it is a host termination. Okay, so this way the running of the graph will be happen at the background level, right? And you will be able to see the output within the GD itself, right? So the execution part is mainly handled with the help of the co-operating system server component. Okay, so any questions here?
No, it's clear.
Okay, another soon.
I'm fine. Thanks,
Yeah. Okay. Okay, fine. Yeah, so this is the communication, right? How it is happening between the GD and the host here, right? So that's what we discussed till now. So you will be having a connection, right, in the GDE to connect to this host machine, right? So whenever you join to any client to work with, right, so you'll be given an access to this host mission, that is your Unix mission, and you'll be given an access to the GDE license, right, will be activated with your ID. Okay, so whenever you log into this host mission, you'll be having a home path, right? That means the root directory is home followed by the developer ID, right? So this is my home path, let's say that, right? Okay, so now I'll be introducing one more component, right? From the architecture level, that is nothing but EME. Okay, that is nothing but EME. So here EME is a repository, right? EME is a repository that is enterprise meta environment, which is a separate software from the Abinitio. Okay, so that means here, whenever you work with the Abinitio as a ETL tool projects, right, everywhere you'll be using the EME as a repository, right? There is nothing like we'll be using the third-party tools, right, as a repository. Okay, so the repository is always EME only, right? So this is installed on the different Unix server, right? This is existing on the different Unix server. So sometimes in some of the projects, right? So we observe that, right? So this EME and this host machine, right? Host is a different Unix server, right? So in this scenario, I am telling that host is a one Unix server and EME is existing on the different Unix server, right? These are two different Unix servers, right? But sometimes you might be seeing that the same Unix server is serving like as a host, as a EME. But in those situations, right? So we faced some problems with the performance, right? And they migrated this EME, right, to the different Unix server so that the burden will not be existing on the different same Unix server, right? So you will not face any problem. Okay, so that means EME is it's a repository where you store the code, right? And it is also a version controlling tool by default, right? It's a version controlling tool. So here I'll be storing all my code, Abinitio code, right, in this EME. Okay, so from the EME only, I'll be migrating the code into the respective higher environments, right? So whenever you do the life cycle, whenever you see the life cycle of the Abinitio, right, or any kind of ETL or anything, you can see here, right? So we have development track, right? So we have SIT, UAT, production, right? So we have different environments available, right, in our warehousing. So you'll be moving the code from one location to other location, right? And finally, it will be in the production. So as a part of Abinitio skill set, so you can work as a ETL developer within the development environment, and you can work like a support analyst in the production support, right? So both the responsibilities, right, will be there in different projects, right? As a support, we'll be working the support analyst also, right? So we can have more opportunities on this front. Okay. And now, like whenever you see this EME, so EME is existing on the Unix server, right? So we have the root directory, which is a projects, right? Which is a projects. So this is constant in the EME. That means to any client, to any project you're working with, right? Any domain. So this projects, root projects is a common directory, right? It's a root directory for every application. But the rest of the folders will be changing as per your client, right? So they will be creating their own subdirectories, right? So they create some directory structure like this, right? And this complete path is called as project path. Okay, its complete path is called as a project path. So I'm using the terminology as project. This is not about your project, whichever you're working with, right? But project is an Abinitio terminology, which is called as a directory structures in the EME to store your code, right? To store your code. That means this is called as a project path, and in this last subdirectory, we'll be having a set of subdirectories, right? Like this. These are again constant. Okay, these are constant again in any application you work with. So MPs will store the graphs, right? MP folder, and run folder will store the .ksh files, right? So this way, each and every folder is having an importance, right? So where the respective objects will be saved, right, into these locations. Okay, so this is existing in the project path, right? So whenever I started working on these projects, right, so I'll be creating my own environment first, right? I'll be creating my own environment. That means I'll be creating a sandbox in my host machine, right? In my host machine, I'll be creating a sandbox. So how do you create it? Means whenever you perform a checkout process, a sandbox will be created, right? That is within your home path, the complete path of the EME project path will be copied into your home path, right? So now this complete path is called as a sandbox, and it is nothing but it is a working environment for a project, right? And it is working environment for a project. Okay, so every user will have their own sandbox. Okay, any questions here?
So far, so good.
Okay. Okay, so a sandbox will be created. So this is my place, right, where I'll be storing my code initially, right? So from the GDE, whenever you create anything, it will be saved under my sandbox, right? So this is my sandbox path, right? So when I created a graph, right, a graph will be saved under MP extension, right? Under MP extension, and this is my graph name, right? So initially the code will be stored in the sandbox, right? But later, once the development and testing is completed, it will be stored in the EME. Okay. So whenever you want to store it in the EME, you have to perform check-in process. Right. So how to do check-in, check-out, we'll see later. But checkout is getting the objects from EME to the sandbox, and check-in means taking the updates from your sandbox to EME. Okay, so you'll be seeing this check-in, check-out process. You can do either from the GDE or from the host machine, right? So if you're doing from the GDE, you'll have an options, right, how to perform check-in, check-out. But if you're doing from the host machine, we should use the commands, right, Abinitio commands to do this check-in, check-out. Okay, so we'll have other commands also to interact with EME. So basically, like every user will be creating the graphs initially in their sandbox, and then they will perform a check-in, right? So whenever you do checkout, the checkout will always try to bring the objects which are missing in your sandbox, but they are present in the EME. Okay, but they are present in the EME, right? That means the missing objects in your sandbox with respect to the EME project, right? That is one thing. And the updates also, right? You have any graph modified in the EME is having the latest version, okay, and you are holding the old version in your sandbox, right? So then it will override the existing object which is existing in your sandbox level, right? The sandbox is not a version controlling tool, but EME is a version controlling tool, right? In the sandbox, we will not maintain multiple versions, right? You'll have only one version. It can be older version or it can be latest version, right? Let's say that, right, I did not do checkout for the last 10 days, right? So from last 10 days, there are 10 graphs which are created as a new, and then they are available in the EME. And we have 5 graphs, right, which are modified, right, in the EME. So whenever you check out after 10 days, right, you'll get all those 10 graphs into your sandbox, and then also your objects, your 5 objects which are updated, right, those are also will be coming out, right? That means into your sandbox. They will get updated. So your sandbox will be up to date in sync with EME. Right? Suppose say if you are trying to modify the existing object in your sandbox, right? Suppose say you are trying to modify the existing object in the sandbox. At that time, you have to lock it. Okay, you have to lock it. That means we are going with the scenario, right? How it is like this. Okay. Okay, there are two developers like A and B, right? So they created A.mp and B.mp, and it is existing in their own sandboxes, right? So developer A is having their own sandbox, B is having its own sandbox, right? And once the graph is to be checked in into the EME, they will perform a check-in, and EME will have both the objects with the two different versions, right? And now when you go for modification, right? Suppose now they want to modify it. So the developer A want to modify both the graphs, A.mp and B.mp, right? But as per the initial step number 1, right? He is having only A.mp, right? So B.mp is not present in the sandbox, right? But whenever he perform a checkout, as this is a new object existing in the EME, it will be copied into his sandbox. So now the sandbox of A will have both the graphs, A.mp and B.mp. We can lock the graphs, right? We can lock the graphs. So locking is required to modify any object which is present in the EME, right? An object which is existing in the EME, if you want to modify it, you have to lock it, right? So once it is locked, you can modify it, and then you can save it. Okay, but yeah, tell me.
Hello.
Hello. Yeah.
So if same person is working on the same, if two different person are working on a same project, after they check out, hello.
Yeah. Tell me.
Can you hear me?
Yeah, you're audible. Go ahead.
So if it's like so 2% can check in on the same graph at a time.
No, that is not possible. That is not possible, right? So suppose you created a graph, right? You created a graph, and then you checked in, right? Okay, and that's what, like, the locking is required, right, to avoid multiple users to modify at the same time, right? So multiple users cannot modify at the same time. Okay, that is why we are locking it.
Okay.
Right? So without locking, even we cannot edit the graph. Right? Without locking, you cannot edit the graph as well, right? So once you logged it and modified it, right, and it will be saved into your sandbox. But whenever you perform check-in, it will be available in the EME, right? And then in the EME, you can see new versions, right? So both the graphs are modified, right? So 101 version A.mp is having a new version with 191, and 201 B.mp is having a new version 234, right? So we have two versions available in the EME, right? So now this the person B, right? The person B, okay, initially he created B.mp, right? So he is trying to lock it. He want to modify something on the same graph, right? He is having this MP, right, in the sandbox first as he created it. So, but he cannot lock it. He is unable to lock it. Why? Because this is the older version when you compare with the EME version, right? So the version which is existing in B.mp, right, in the B user, right? What is the version number? It will be 201. Okay, it will be 201, right? So 234 is been created by this new developer A. So he did not do any checkout, right? He tried to lock it. So the older version cannot be locked. Hello? Able to hear me? Hello.
Are you, Kumar?
Oh, you can hear, right? So what is the problem here and the other? Like I'm in the same mode, right? I did not change anything. So Vamsi, you are not able to hear me? Hello, Vamsi. Hello.
Kumar, hello.
Yeah.
Now
Yeah,
we are
able
able to hear you. Like for 2-3 minutes, it was not audible.
Yeah.
We were not here, and now we are.
Okay, fine. Yeah, there is some problem at your end, I think, right? So Rasuni is able to hear.
Yeah, I can.
Yeah. Okay, fine. What I'm saying here is, right? So the user A has modified 2 graphs, right? And he checked in so that these versions are available in the EME, right? So you have created 191 and 234 versions in the EME, right, by this user. Okay, and now the user B want to modify the graph b.mp, right? But b.mp in his sandbox is older version. So whenever he try to lock it, he cannot lock it, right? Why? Because it is the older version. It will pop up a window stating that the version is available is not in sync with the EME version. So in order to modify any graph which is present in the EME, okay, it should be the same version, the latest version of the EME should be available in your sandbox, right? Then only you can modify it. If not, you cannot modify this graph, right? So he will be performing a checkout and he will get a.mp updated. A.mp will be added up and b.mp will be the latest version, right? Which will be updated. Okay, so this way he will modify it, right? This check-in checkout is not a one-time process. It will be the regular process. Hello, Vamsi. Hello. Okay, fine. Rasul, any questions for you?
Okay, and also, okay, no, it's not able to hear. Okay, hello. Okay, actually, like the examples wise, right? Like we want a little more, maybe somewhat advanced actually, because we had a bit of understanding already.
Okay.
Yeah. So, yeah, because we want to work in a real time, like how well the examples will be, because for us it's more important to have the real time examples, really good ones.
Yeah. We have it anyhow. Like as we are giving the real-time scenarios only, right? So all the assignments will be right. So once you complete those things, right? So we'll be having more and more.
Okay. And how many classes overall?
One month.
Okay, and it's like 1.5 hour session or 1 hour session?
1 hour session.
Okay.
Okay. So any other questions?
No.
I'm also good. Thank you.
Okay. Fine then. We'll meet in the actual sessions, and then like what I need is right. So you need to work on the guidelines, right? Whatever I am giving it to you. So by the time you complete the course, right, you'll be able to work on the projects directly, right? So we have to put some. Yeah.
Will you be just covering the topics on the whole, or you will explain them in detail? Like, for example,